What if I told you that the edge of the universe isn't an edge at all? That right now, as you're watching this video, there are potentially infinite copies of you making different choices in universes stacked beyond our cosmic horizon. And here's the part that will absolutely shatter everything you thought you knew. The greatest minds in physics are now saying that our entire universe might be nothing more than a hologram projected from the boundary of something far, far larger. I know what you're thinking. This sounds like science fiction. But in the next 3.5 hours, I'm going to take you on a journey that will fundamentally change how you see reality itself. We're going to explore what Nobel Prize-winning physicists are actually discovering about the limits of existence. And trust me, the truth is stranger than any fiction. Here's what will blow your mind. When astronomers point their most powerful telescopes at the deepest reaches of space, they're not finding an edge. They're finding something far more bizarre. They're finding evidence that space itself is doing something that shouldn't be possible, something that suggests our universe is just one bubble in an ocean of existence that might have no end. Before we dive in, do me a favor. Hit that like button right now, because this video took months of research to put together, and the algorithm needs to know you're ready for your mind to be expanded. Subscribe and turn on notifications, because we're about to go places your high school physics teacher never told you about. And drop a comment telling me where you're watching from and what time it is in your time zone. I want to know how many of you are losing sleep over cosmic mysteries just like I am. Let's begin. To understand what exists beyond the universe, we first need to understand what we mean by the universe. And right here, at the very beginning, I need to surprise you with something most people get wrong. When scientists talk about the universe, they're not talking about everything that exists. They're talking about everything we can possibly observe. And that's a crucial difference. Think of it like this. Imagine you're standing in the middle of a perfectly flat desert that goes on forever in all directions. You can only see about 3 miles to the horizon because of the curvature of the earth and the limits of your vision. Does the desert end at your horizon? Of course not. It keeps going. Your horizon is just the limit of what you can observe, not the limit of what exists. The universe works the same way. We have what astronomers call observable universe, and it's enormous. We're talking about 93 billion light years across. To put that in perspective, light travels at 186,000 miles per second, and it would take light 93 billion years to cross from one side of our observable universe to the other. Inside this observable universe, there are approximately 2 trillion galaxies, each containing hundreds of billions of stars. But here's the twist that changes everything. The observable universe is just our cosmic horizon. It's not the edge of existence. It's the edge of what we can see. Why do we have this horizon? Because the universe has an age. It's approximately 13.8 billion years old, a date we've confirmed through multiple independent methods, including measurements of the cosmic microwave background radiation by the Planck satellite in 2013. Since the universe has an age, and since light takes time to travel, there's a limit to how far we can see. Light from beyond a certain distance simply hasn't had time to reach us yet. But wait. You might be thinking, if the universe is 13.8 billion years old, shouldn't we only be able to see 13.8 billion light years in each direction, making the observable universe only 27.6 billion light years across? This is where things get weird. The universe is expanding. Not just expanding, but expanding in a way that carries galaxies apart faster than light can travel between them. This doesn't violate Einstein's cosmic speed limit, because the galaxies themselves aren't moving through space faster than light space itself is expanding between them. It's like drawing dots on a balloon and then inflating it. The dots move apart, but they're not moving across the balloon's surface. This expansion was discovered by Edwin Hubble in 1929, and it's named the Hubble expansion in his honor. Using the Mount Wilson Observatory's 100-inch telescope, Hubble measured the redshift of distant galaxies and found that the farther away a galaxy was, the faster it was moving away from us. This single observation changed cosmology forever. Because of this expansion, objects that emitted light 13.8 billion years ago are now much farther away than 13.8 billion light years. They've been carried away by the expansion of space itself. This is why our observable universe is 93 billion light years across, not 27.6 billion. Now, here's where your mind should start tingling. If the universe is expanding, what is it expanding into? This is the question that leads us to the edge of the universe and beyond. And the answer is going to challenge your most basic assumptions about space, time, and existence itself. What if I told you that the universe might not be expanding into anything at all? That the entire question of, what is space expanding into, might be based on a misunderstanding of what space actually is? Here's what will blow your mind. Space isn't a container that things exist inside of. Space is a relationship between things. When the universe expands, it's not expanding into some pre-existing void. Space itself is being created as the universe expands. There is no outside for it to expand into, because outside is a spatial concept, and space only exists within the universe. This is hard to wrap your brain around, because every expansion we experience in daily life involves something expanding into something else. A balloon expands into the air around it. A city expands into the countryside. But the universe isn't like that. The universe is all of space itself. To understand this, we need to talk about the shape of the universe. And this is where things get truly mind-bending. There are 3 possible shapes the universe could have, and each one has profound implications for what exists beyond our cosmic horizon. First possibility: the universe is flat. Not flat like a pancake, but flat in a geometric sense. In a flat universe, parallel lines never meet. The angles of a triangle add up to exactly 180 degrees, and the universe extends infinitely in all directions. If the universe is flat and infinite, then beyond our observable universe, there's just more universe. More galaxies, more stars, more planets, extending forever. Second possibility: the universe is positively curved, like the surface of a sphere. In this geometry, parallel lines eventually converge. The angles of a triangle add up to more than 180 degrees. And if you traveled far enough in one direction, you'd eventually come back to where you started. In a positively curved universe, the universe would be finite, but unbounded. It would have no edge, but it wouldn't go on forever. Third possibility: the universe is negatively curved, like a saddle shape. In this geometry, parallel lines diverge. The angles of a triangle add up to less than 180 degrees, and the universe would be infinite with a very particular structure. So which is it? This is where real science gives us a shocking answer. In 2013, the Planck satellite measured the cosmic microwave background radiation, the afterglow of the Big Bang, with unprecedented precision. What they found is that the universe appears to be flat to within a margin of error of less than 0.4%. If the universe is truly flat, and if our best measurements suggest it is, then it's almost certainly infinite. Think about what this means. Beyond our observable universe, there's just more universe. More galaxies we'll never see. More stars we'll never observe. More planets we'll never visit. And here's where it gets absolutely wild. If the universe is infinite, and the laws of physics are the same everywhere, then everything that can happen must happen somewhere, including exact copies of you. I'm not joking. This is a serious consequence of an infinite universe, first explored in detail by cosmologist Max Tegmark in 2003. If space is infinite and matter is distributed roughly evenly throughout it, which our observations suggest is true, then every possible arrangement of particles must occur somewhere. The number of ways particles can be arranged in any given volume of space is huge, but it's finite. In an infinite universe, even finite possibilities must repeat. Statistical mechanics tells us that somewhere out there, Beyond our cosmic horizon, there's a region of space where particles have arranged themselves into an exact copy of Earth, with an exact copy of you, making the exact same choices you're making right now. In fact, there are infinitely many such copies. Some of them are making different choices. Some of them are living completely different lives. This isn't speculation. This is a mathematical consequence of infinity combined with the laws of probability, and it's one of the most profound implications of what exists beyond the universe we can see. But wait, because we're just getting started. The flat, infinite universe is just one possibility. And even if it's correct, it's not the full story, because there are other beyonds we haven't even touched on yet. What exists beyond the universe? The answer might be other universes, plural, and not just a few. We're talking about a potentially infinite number of separate universes, each with its own laws of physics, its own constants of nature, its own history. Welcome to the multiverse. And before you dismiss this as science fiction, let me tell you about the scientists who take this idea very seriously. In 2003, cosmologist Max Tegmark, now at MIT, published a groundbreaking paper in Scientific American proposing a 4-level classification system for different types of multiverses. Each level represents a different type of beyond to our observable universe. And each level is more mind-blowing than the last. Level 1 is what we just discussed, the infinite extension of our own universe beyond our cosmic horizon. Same laws of physics, same fundamental constants, just more space with different arrangements of matter. This is the most conservative multiverse theory because it requires only that the universe is infinite, which our best measurements suggest it is. Level 2 is where things start to get wild. This is the multiverse of eternal inflation, and it's based on a theory developed by physicist Alan Guth at MIT in 1981. Here's how it works. The Big Bang wasn't a single explosion at a single point. It was an exponentially rapid expansion of space called inflation, which occurred in the first fraction of a second after the universe began. During this inflationary period, space expanded faster than light, doubling in size every tiny fraction of a second. But here's the key insight. Inflation might not have stopped everywhere at the same time. Quantum fluctuations would have caused some regions to stop inflating while others continued. Each region that stopped inflating became a bubble universe, a separate domain with its own physical properties. Meanwhile, the regions still inflating continued to grow and spawn new bubble universes. This process, called eternal inflation, means that inflation never truly ends. It keeps creating new bubble universes forever, each potentially with different physical laws. Our observable universe is just one bubble in an infinite ocean of bubbles, separated from each other by regions of still inflating space. And here's what will blow your mind. These other bubble universes aren't just far away in space. They're fundamentally disconnected from us. The space between bubbles is expanding so fast that no signal, no matter how fast, could ever travel from one bubble to another. These universes are beyond our universe in a way that makes them truly unreachable. Level 3 is the quantum multiverse, based on the many worlds interpretation of quantum mechanics. This interpretation was proposed by physicist Hugh Everett III in 1957, and it's experiencing a major resurgence among physicists today. In quantum mechanics, particles exist in what's called superposition, occupying multiple states simultaneously until they're observed. The famous Schrödinger's cat thought experiment illustrates this. A cat in a box is both alive and dead until you open the box and observe it. The many worlds interpretation says that when you open the box, the universe splits into two branches. In one branch, the cat is alive. In another branch, the cat is dead. Both outcomes happen, just in different versions of reality. Every quantum measurement, every quantum event, causes the universe to branch into multiple versions, each representing a different possible outcome. This means that every decision you've ever made has created branching timelines. There are versions of you who made different choices, living different lives in universes that are just as real as this one. These parallel universes aren't far away in space. They're separated from us in a different way, in what physicists call Hilbert space, the mathematical space of quantum possibilities. Level 4 is the ultimate multiverse, the mathematical universe hypothesis. This is Max Tegmark's own radical proposal. He suggests that all mathematically consistent structures exist as physical realities. If a set of mathematical equations is logically consistent, then somewhere, somehow, it describes an actual universe. This would mean there are universes with different numbers of dimensions, different fundamental forces, different types of particles, even different mathematical structures underlying reality. Every possible mathematical structure is realized as a physical universe somewhere in this ultimate ensemble. Now, I know what you're thinking. This all sounds crazy. Why should we believe any of this? Here's the thing. We don't believe it in the sense of having proof. These are theoretical frameworks based on extensions of well-tested physics, but they're not random speculation. Each level of the multiverse emerges from taking our best current theories and following them to their logical conclusions. Eternal inflation follows from the inflationary theory that explains multiple observed features of our universe, including its flatness and the distribution of galaxies. The many worlds interpretation solves genuine problems in quantum mechanics, which is the most precisely tested theory in all of science. The mathematical universe hypothesis is more speculative, but it addresses deep questions about why our universe has the mathematical structure it does. The multiverse isn't just a wild idea. It's what happens when you take seriously what our best physics is telling us about reality. And we're about to go even deeper. Before we continue, I want you to pause for a second and think about what we've just covered. We started with a simple question: what exists beyond the universe? And we've already discovered that the answer might involve infinite copies of you, bubble universes with different laws of physics, quantum parallel worlds, and mathematical structures as real as physical reality. And we're only about 40 minutes in. We haven't even touched on the most mind-bending ideas yet. Coming up, we're going to explore the holographic principle, which suggests our entire three-dimensional universe might be a projection from a two-dimensional boundary. We're going to examine what quantum physics tells us about the fundamental nature of space and time. And we're going to confront the possibility that existence itself might be infinite in ways we can barely comprehend. If you haven't already, smash that subscribe button, because we're going places most science channels won't dare to go. Drop a comment telling me which level of the multiverse blows your mind the most so far. And stick with me, because the rabbit hole goes much, much deeper. Let's continue. What if I told you that you're not really three-dimensional? That everything you experience, your body, the room you're in, the planet you're standing on, is actually a two-dimensional projection, like a hologram, of information encoded on a distant cosmic boundary. This isn't philosophy. This is cutting-edge theoretical physics, and it's called the holographic principle. And if it's true, it completely transforms our understanding of what exists beyond the universe. The holographic principle emerged from the study of black holes, those cosmic objects so dense that not even light can escape their gravitational pull. In the 1970s, physicist Stephen Hawking made a shocking discovery. Black holes have a temperature, and they emit radiation. This radiation, now called Hawking radiation, means that black holes slowly evaporate over time. But this created a paradox. When a black hole evaporates, what happens to all the information about the matter that fell into it? The laws of quantum mechanics say that information can't be destroyed, but if a black hole evaporates completely, where did that information go? This became known as the black hole information paradox. In 1993, physicists Gerard T. Hooft and later Leonard Susskind proposed a radical solution. They suggested that all the information about what falls into a black hole isn't stored in the three-dimensional volume of the black hole. Instead, it's encoded on the two-dimensional surface of the black hole's event horizon, the boundary beyond which nothing can escape. Think of it like this. Imagine a three-dimensional object and its two-dimensional shadow. The shadow contains all the information about the object's shape, just in a different form. Similarly, all the information about the three-dimensional interior of a black hole is encoded on its two-dimensional surface. But here's where it gets truly wild. T. Hooft and Susskind realized that if this is true for black holes, it might be true for the entire universe. Maybe all the information about our three-dimensional universe is actually encoded on a two-dimensional boundary at the edge of spacetime. This idea was given mathematical precision by physicist Juan Maldacena in 1997. He proved that a specific type of universe with a negative curvature called anti-de Sitter space is mathematically equivalent to a quantum field theory living on the boundary of that space. This is called the ADS-CFT correspondence, and it's one of the most important discoveries in theoretical physics in the past 30 years. What this means is that our three-dimensional reality might be a holographic projection from a two-dimensional surface. Just like a hologram on a credit card looks three-dimensional, but is actually encoded in a two-dimensional pattern, our universe might be a hologram projected from information stored on a cosmic boundary. Now, our universe isn't anti-de Sitter space. It has a positive curvature, not a negative one. But many physicists believe that some version of the holographic principle applies to our actual universe. If it does, and what exists beyond the universe isn't another place in space. It's a lower dimensional encoding of everything that exists. This has profound implications. It means that space itself, as we experience it, isn't fundamental. It's emergent, arising from relationships between information encoded on a boundary. The three-dimensional world you see around you is like a very convincing illusion, a projection from something more fundamental. But here's what will really blow your mind. If the holographic principle is correct, then the amount of information in any region of space isn't proportional to the volume of that region. It's proportional to the surface area of the boundary surrounding that region. This is completely counterintuitive. You'd think that if you doubled the radius of a sphere, you'd have 8 times as much volume and therefore 8 times as much information. But the holographic principle says you only have 4 times as much information, because the surface area only increased by a factor of 4. This has been confirmed in certain theoretical models, and strongly suggests that what we think of as three-dimensional space is actually a holographic projection. Space has one less dimension than it appears to have. So when we ask what exists beyond the universe, one answer is, the universe itself exists as information on a boundary, and what we experience as inside the universe is actually a holographic projection from that boundary. A boundary is the beyond. This is a very different kind of beyond than the multiverse theories we discussed earlier. It's not beyond in the sense of being farther away in space. It's beyond in the sense of being more fundamental, more real than the space we inhabit. And we're just scratching the surface of how strange reality gets at its deepest levels. Let's zoom in instead of out. What if I told you that if you could look at space at its smallest possible scale, it wouldn't be smooth and continuous? That at the tiniest scales, space itself is bubbling and frothing like quantum foam, with virtual black holes popping in and out of existence, and the very fabric of reality becoming uncertain and probabilistic? Welcome to the Planck scale, where space and time themselves break down. There's a fundamental limit to how small we can go, how finely we can divide space and time. This limit is called the Planck length, and it's approximately 1.6 times 10 to 35 meters. That's a decimal point, followed by 34 zeros, and then a 16. To put this in perspective, a Planck length is to an atom what an atom is to our entire solar system. The Planck length was derived by physicist Max Planck in 1899 by combining 3 fundamental constants of nature: the speed of light, the gravitational constant, and Planck's constant from quantum mechanics. It represents the scale at which quantum effects of gravity become significant. At distances smaller than the Planck length, our current theories of physics break down. General relativity, Einstein's theory of gravity, and quantum mechanics, our theory of the very small, both work beautifully in their own domains. But they're mathematically incompatible with each other. When you try to apply both theories at the Planck scale, you get infinities and nonsensical answers. This tells us that something fundamental changes at the Planck scale. Space and time, as we understand them, probably don't exist in their usual form. Physicist John Wheeler, who coined the term black hole, proposed in the 1950s that at the Planck scale, space becomes quantum foam. Just as the surface of the ocean looks smooth from an airplane, but reveals waves and turbulence up close, space appears smooth at large scales, but becomes violent and chaotic at the Planck scale. At this scale, quantum fluctuations become so intense that space itself fluctuates. Virtual particle-antiparticle pairs pop in and out of existence. Tiny wormholes might connect different points in space. Miniature black holes might form and evaporate in tiny fractions of a second. The very topology of space becomes uncertain, probabilistic, fundamentally unpredictable. This suggests that space isn't a smooth continuum. At its deepest level, it might be discrete, made of tiny indivisible units, like pixels on a screen. If you zoom in far enough, you find that space has a graininess, a quantum structure. Several approaches to quantum gravity support this idea. Loop quantum gravity, developed by physicists Carlo Rovelli and Lee Smolin in the 1990s, described space as being made of tiny loops called spin networks. These loops are the quantum units of space itself. Space, in this view, is fundamentally discrete, not continuous. String theory, another approach to quantum gravity, suggests that the fundamental constituents of reality aren't particles, but tiny vibrating strings. These strings exist at the Planck scale, and the different vibrational modes of these strings correspond to different particles and forces. In string theory, space might have extra dimensions curled up at the Planck scale, dimensions we can't perceive because they're so small. So what exists beyond the universe at the smallest scales? The answer might be that there is no beyond. Space and time might be emergent properties that arise from something more fundamental at the Planck scale. Just as temperature emerges from the motion of atoms, but isn't a property of individual atoms, space and time might emerge from quantum information or other quantum entities, but they aren't fundamental. This is a radically different way of thinking about reality. Space isn't a stage on which physics happens. Space is something that physics creates. And at the Planck scale, that creation becomes obvious. Here's what will blow your mind. If space and time are emergent, then the question, what exists beyond the universe, might not even make sense. Beyond is a spatial concept. Universe refers to all of space and time. If space and time aren't fundamental, then asking what exists beyond them is like asking what's north of the North Pole. The question itself is based on a category error. But that's not the end of the story. Because there's another kind of beyond we haven't explored yet. The beyond that exists in the structure of reality itself. What if mathematics isn't something humans invented to describe the universe? What if mathematics is the universe? What if numbers, equations, and geometric forms exist in a realm more real than the physical world, and what we call the physical universe is just a shadow of mathematical truth? This is Platonism, and it's making a comeback in modern physics in a big way. The ancient Greek philosopher Plato proposed that abstract forms, perfect circles, perfect triangles, perfect concepts exist in a realm of pure forms, and the physical world is just an imperfect reflection of these perfect abstractions. For centuries, this was considered interesting philosophy, but not particularly relevant to science. But modern physics has forced us to reconsider. The universe is shockingly mathematical, not just describable by mathematics, but seemingly made of mathematics. Consider this. Physicist Eugene Wigner wrote a famous paper in 1960 titled, "The Unreasonable Effectiveness of Mathematics in the Natural Sciences." He pointed out something strange. Mathematics developed for purely abstract reasons, with no thought of physical application, repeatedly turns out to describe physical reality with stunning precision. For example, mathematician William Rowan Hamilton invented quaternions in 1843 as a purely mathematical curiosity. Over a century later, quaternions became essential for describing quantum spin. Mathematician Bernhard Riemann developed his geometry of curved spaces in the 1850s purely as abstract mathematics. 50 years later, Einstein realized that Riemann's geometry was exactly what he needed to describe gravity in general relativity. This pattern repeats over and over. Mathematics that seems purely abstract and disconnected from reality turns out to be the language the universe speaks. Why? One possibility is that mathematics exists in a Platonic realm, independent of physical reality, and the physical universe is somehow constrained to follow mathematical rules. Another possibility, the one Max Tegmark champions in his Level 4 multiverse, is that the physical universe is mathematics. There's no distinction between mathematical structures and physical reality. Mathematical existence and physical existence are the same thing? If this is true, then what exists beyond our physical universe is the entire landscape of mathematical possibility. Every logically consistent mathematical structure exists as a physical reality somewhere in the ultimate multiverse. Think about what this means. Our universe is described by particular equations, the equations of quantum field theory, general relativity, the standard model of particle physics. These equations have specific parameters, like the strength of gravity, the mass of electrons, the speed of light. In our universe, these parameters have particular values. But mathematics allows for different values of these parameters. It allows for different equations altogether. If all mathematical structures exist as physical realities, then there are universes with different forces, different particles, different numbers of dimensions, different mathematical structures entirely. Some of these universes would be unimaginably strange. Universes where time has multiple dimensions. Universes where space is non-commutative, meaning the order in which you travel matters. Universes governed by equations we haven't even discovered yet. This provides a potential answer to one of the deepest questions in physics. Why do the laws of nature have the form they do? Why these equations and not others? If all mathematical structures exist as physical realities, then our universe's laws aren't special. They're just one possibility among infinitely many, and we observe these particular laws because we exist in a universe where these laws allow for complex structures like stars, planets, and life. But here's the truly mind-bending part. If mathematical structures exist in a Platonic realm, independent of physical space-time, then this Platonic realm is a kind of beyond to our universe. It's not beyond in space or time. It's beyond in the hierarchy of existence. Mathematical truth is more fundamental than physical reality. This realm would contain all possible truths, all possible patterns, all possible structures. The Mandelbrot set, that infinitely complex fractal pattern, exists in this realm whether or not anyone ever discovers it or draws it. The proof of the Pythagorean theorem exists in this realm independent of whether ancient Greeks or anyone else ever figures it out. And if our universe is just one mathematical structure among many, then the Platonic realm of mathematical forms is the ultimate beyond to the universe. It's the space of all possibilities, the set of all sets, the realm of pure existence. Some physicists and philosophers find this idea deeply troubling. How can abstract mathematics be more real than concrete physical reality? Others find it beautiful and explanatory. It answers why the universe is mathematical, why mathematical truth is universal and unchanging, and why different mathematical structures can describe different physical situations. What exists beyond the universe? If Platonism is correct, what exists beyond is pure mathematics, the realm of eternal truths and infinite possibilities. And we still have more beyonds to explore. Take a breath. We've covered an enormous amount of ground. We've explored spatial infinities, bubble universes, quantum parallel worlds, holographic projections, quantum foam, and platonic mathematical realms. Each one is a different kind of beyond to our observable universe. But we're only at the 90-minute mark. We're about to shift gears and get personal. How does all of this affect you? Why should you care about what exists beyond the universe? What does it mean for your life, your choices, your place in the cosmos? Coming up, we're going to explore the philosophical and personal implications of everything we've discussed. We're going to confront questions about meaning, purpose, and the significance of your existence in a potentially infinite multiverse. We're going to examine what modern cosmology tells us about free will, determinism, and the nature of consciousness. If you're still with me, drop a comment about which concept has been the most challenging to wrap your head around. Hit that like button if your brain hurts in the best possible way. And make sure you're subscribed, because we're about to make this deeply, profoundly personal. Let's continue. Here's something that will mess with your head. If the multiverse is infinite, then every possible event, no matter how unlikely, happens infinitely many times. So how do we make sense of probability in an infinite multiverse? This is called the measure problem, and it's one of the deepest puzzles in modern cosmology. Let me give you an example. Imagine flipping a coin. In a single universe, you have a 50% chance of getting heads and a 50% chance of getting tails. But in an infinite multiverse with quantum branching, both outcomes happen. There's a branch where you get heads and a branch where you get tails. Now flip the coin 1,000,000 times. In a single universe, the probability of getting heads every single time is unimaginably small, 1 in 21 million. But in an infinite multiverse, there's a branch where this happens. In fact, there are infinitely many such branches. So how do we make sense of probability? If every outcome happens somewhere, what does it mean to say one outcome is more likely than another? Physicist Andre Lind, one of the founders of inflationary cosmology, has spent years wrestling with this problem. In eternal inflation, where new universes are constantly being created, you have to ask, how do you count universes? If there are infinitely many universes, and infinitely many of them have any given property, how do you compare probabilities? This isn't just a theoretical curiosity. It affects real predictions. For example, we'd like to use the multiverse to explain why our universe has the physical constants it does. We could say, most universes have constants that don't allow for life, but we observe our particular constants because we couldn't exist in universes with different constants. This is called the anthropic principle. But if there are infinitely many universes with life-permitting constants and infinitely many without, you can't simply say one type is more common. Infinity divided by infinity is undefined. You need a way to measure which type is more common in some meaningful sense. This is the measure problem. And it's deep. Different ways of defining the measure, different ways of comparing infinities, give you different predictions about what we should observe. Some proposed solutions involve cutting off infinity at some finite time or finite volume and taking a limit. Others involve weighting different regions of the multiverse, differently based on their information content or other properties. But there's no consensus on the right answer. Here's what will blow your mind. The measure problem suggests that our intuitions about probability might break down in an infinite multiverse. Probability theory was developed for finite sample spaces. Extend it to infinity, and you get paradoxes. Consider the Boltzmann brain problem. Ludwig Boltzmann, the 19th century physicist, realized that if you wait long enough, random quantum fluctuations will eventually assemble any structure, no matter how complex, just by chance. Given infinite time, random fluctuations will assemble a brain with false memories of an entire life, complete with beliefs about living in a universe like ours. In an infinite multiverse with infinite time, there are infinitely many such Boltzmann brains. And there are also infinitely many real brains like yours, created through the normal process of stellar evolution, planet formation, and biological evolution. But depending on how you do the counting, there might be more Boltzmann brains than real brains. If that's true, then the most likely explanation for your existence is that you're a Boltzmann brain, a random fluctuation that will disappear in the next instant, rather than a real person in a real universe. This conclusion is absurd, which suggests something is wrong with our counting method. The measure problem is forcing physicists to think deeply about what it means for something to exist, what it means for one thing to be more common than another, and what we can meaningfully predict in an infinite multiverse. And here's the personal connection. If there are infinitely many copies of you in the multiverse, does that make you less significant? Or more significant? If every possible version of your life is being lived somewhere, does that change how you should think about your choices? We're going to explore these questions in depth. But first, we need to talk about consciousness, because that's what makes this personal. Let's make this real. Let's talk about you, not as an abstract concept, but as a conscious being having an experience right now, at this moment, watching this video. What if I told you that your consciousness might be the most mysterious thing in the entire multiverse? That despite all our knowledge about quantum mechanics, relativity, cosmology, and fundamental physics, we have almost no idea what consciousness is or why it exists. This is called the hard problem of consciousness, and it's fundamentally connected to what exists beyond the universe. Here's the puzzle. Physics can explain how neurons fire, how information is processed in the brain, how sensory data is integrated and transformed. But physics can't explain why there's something it feels like to be you, why you have subjective experience, why there's an inner light of consciousness. Philosopher David Chalmers formulated the hard problem in 1995. He pointed out that there's a difference between the easy problems of consciousness explaining cognitive functions like attention, memory, and behavior, and the hard problem, explaining why any of this is accompanied by subjective experience. You could imagine a zombie universe where all the physical facts are the same as our universe neurons firing, information processing, complex behavior, but nobody's home. No subjective experience, no consciousness. The hard problem is, why isn't our universe like that? Why is there something it feels like to be you? And here's where this connects to what exists beyond the universe. If consciousness can't be reduced to physical processes, then consciousness might exist in a different realm than the physical universe. It might be a fundamental feature of reality, like space, time, and matter. Or it might be connected to information, or mathematics, or some other structure that underlies physical reality. Some physicists and philosophers have proposed that consciousness is fundamental. Physicist Max Tegmark has suggested that consciousness might be a particular type of information processing, characterized by certain mathematical properties. Neuroscientist Giulio Tononi has developed integrated information theory, which proposes that consciousness is identical to integrated information, and any system with high integrated information has consciousness. If consciousness is fundamental, then it exists beyond the physical universe in the sense that it's not reducible to physics. It's an additional layer of reality, as real as quarks and electrons, but of a completely different type. Other thinkers have proposed panpsychism, the idea that consciousness is a fundamental property of all matter, and complex consciousness like yours emerges from simpler forms of consciousness present in simpler systems. In this view, electrons have a tiny bit of consciousness, atoms have a bit more, molecules even more, and brains have rich, complex consciousness. This might sound crazy, but it solves certain problems. If consciousness is fundamental and universal, then the hard problem dissolves. There's no mystery about how physical processes create consciousness, because consciousness was there all along, just in simpler forms. Now, here's what will blow your mind. if consciousness is fundamental, and if the multiverse exists, then there are forms of consciousness throughout the multiverse that we can barely imagine. Conscious systems with different types of qualia, different ways of experiencing reality, different relationships between their experience and the physical processes that support them. There might be universes where consciousness is more fundamental than it is in ours, where the relationship between mind and matter is completely different. There might be universes where every particle is conscious, where the entire universe is a single unified conscious experience. And if consciousness is fundamental, then asking what exists beyond the universe necessarily includes asking about realms of consciousness beyond our own. But let's bring this back to you specifically. You are a conscious being. Right now, you're having an experience. You're seeing these words, hearing my voice, having thoughts and feelings about what you're learning. That experience is real. It's the most directly real thing you know. Everything else, the physical world, other people, the universe itself, you know through your consciousness. Philosopher René Descartes famously said, "I think, therefore I am." Your consciousness is the one thing you can't doubt. You might be wrong about the external world. You might be a brain in a vat, or a Boltzmann brain, or a character in a simulation. But you can't be wrong about the fact that you're having an experience. The experience itself is undeniable. So when we ask what exists beyond the universe, we're not just asking about physical space, or mathematical structures, or other dimensions. We're asking about the realm that contains your consciousness, your subjective experience, the very fact that there's something it's like to be you. And that realm might be the most fundamental, beyond of all. What if the ultimate beyond to our universe is that our universe isn't the base level of reality at all? What if we're living in a simulation, a computer program running in some higher level reality? This is the simulation hypothesis. And before you dismiss it as science fiction, let me tell you why serious philosophers and physicists take it seriously. The argument was popularized by philosopher Nick Bostrom at Oxford University in 2003, though the idea is older. Here's the logic. If it's possible to create detailed simulations of conscious beings, and if any civilization reaches the technological capability to do so, they would likely create many such simulations. Therefore, there would be far more simulated consciousnesses than real ones. Therefore, statistically, you're more likely to be in a simulation than in base reality. This argument has three premises. First, it must be possible to create conscious simulations. Second, civilizations must survive long enough to develop this technology. Third, at least some civilizations must choose to run such simulations. If all three premises are true, then the number of simulated realities vastly outnumbers base reality. Think about it. One base reality could spawn millions of simulated realities, each of which could spawn millions more. The ratio of simulated consciousnesses to real ones approaches infinity. Bostrom argues that at least one of three things must be true. Either civilizations go extinct before reaching simulation capability, or civilizations choose not to run ancestor simulations, or we're almost certainly in a simulation. Now, you might think this is unfalsifiable speculation. But physicists have proposed ways we might detect if we're in a simulation. If our universe is a simulation running on a finite computational substrate, there might be limits to how finely space and time can be divided. This could show up as anomalies in high-energy physics or cosmological observations. Some physicists have pointed out that our universe has mathematical laws, which is exactly what you'd expect if it were a simulation. A simulation has to run on algorithms, which are mathematical. The fact that our universe is so precisely mathematical might be evidence that it's computational. Physicist James Gates Jr. discovered something remarkable in 2012 when he studied the equations of supersymmetry, a theory in particle physics. He found embedded within them error-correcting codes identical to those used in web browsers and telecommunications. Error-correcting codes are a hallmark of digital information systems. Why would they appear in fundamental physics unless reality is computational? If we are in a simulation, what exists beyond our universe is the hardware and software running the simulation, plus whoever or whatever created it. Our universe would be nested inside another reality, which might itself be nested inside yet another reality. There could be layers upon layers, turtles all the way up. This connects to what we discussed about mathematical reality. If all mathematical structures exist, then all possible simulations exist within those structures. Every possible program, running on every possible computational substrate, exists as a mathematical reality. Our universe might be one such program. Here's what will blow your mind. You can't distinguish between a simulated universe running in some higher reality and a mathematical universe existing as pure mathematics. Both are fundamentally computational. Both are information processing according to rules. The distinction might be meaningless. Now, some physicists and philosophers strongly resist the simulation hypothesis. They argue that consciousness can't be simulated, that subjective experience requires something beyond computation. They point out that the simulation argument makes unfalsifiable predictions. If we can't test it, it's not science. But other thinkers find the hypothesis compelling precisely because it explains why the universe is mathematical and computational, and it provides a different kind of beyond to the universe, a hierarchy of nested realities, each simulating the next. If you are in a simulation, does that make you less real? This is a deep philosophical question. The experiences you're having are real to you. The people you love, the pain you feel, the joy you experience, all of that is as real as anything in the base reality. Being in a simulation doesn't make your life meaningless. In fact, it might make it more meaningful. If someone or something cares enough to simulate your existence, to allocate computational resources to your consciousness, perhaps that's a kind of significance. You exist because you are worth simulating. And here's a thought. If we develop the ability to create conscious simulations, we would have ethical obligations to those simulated beings. We couldn't simply turn off the simulation without committing mass murder. We'd be responsible for the welfare of the beings we created. Maybe our creators, if they exist, feel the same responsibility toward us. Maybe the fact that we continue to exist, that the simulation hasn't been terminated, is evidence that something cares about us. Or maybe we're in a simulation, created for some purpose we can't fathom, running according to rules we're just beginning to understand. Either way, the simulation hypothesis adds another layer to what exists beyond the universe. The possibility that our entire reality is contained within something greater, something we can't directly observe, but whose existence is implied by the nature of our universe itself. What if I told you that the future already exists? That everything that will ever happen to you has already happened, is happening now, exists eternally in a four-dimensional structure where past, present, and future are all equally real? Welcome to the block universe, and it's what Einstein's theory of relativity strongly suggests about the nature of time. We experience time as flowing. We remember the past, experience the present, and anticipate the future. The past is gone. The future hasn't happened yet, and only the present moment is real. This is called presentism, and it matches our intuition about time. But relativity tells a different story. In special relativity, Einstein showed that simultaneity is relative. Two events that are simultaneous for one observer might not be simultaneous for another observer moving at a different speed. There's no universal, now that all observers agree on. Think about what this means. If there's no universal present moment, then the past and future must be just as real as the present. They're just located at different positions in time, the same way distant places are located at different positions in space. This view is called eternalism, or the block universe. In the block universe, all of space-time, all of space at all times exists as a single four-dimensional structure. Time is just another dimension, like the three spatial dimensions, and the entire history of the universe from beginning to end exists eternally as a single block. You exist not as a thing that moves through time, but as a four-dimensional object extended through time. Your entire life, from birth to death, exists as a time-like curve through space-time. The you of yesterday, the you of today, and the you of tomorrow all exist simultaneously in different locations in the time dimension. Physicist Brian Greene, who works at Columbia University, has written extensively about the block universe. He points out that if you could somehow view the universe from outside, you'd see all of time at once. You'd see dinosaurs, ancient civilizations, modern cities, and whatever comes in the future, all existing simultaneously in the four-dimensional block. This has profound implications for what exists beyond the universe. If the block universe is real, then beyond includes not just other places in space, but all of time. The distant past and far future are just as much beyond as distant galaxies. But here's what will really mess with your head. If the block universe is true, what about free will? If the future already exists, if your choices tomorrow are already real, locked into the structure of space-time, can you really choose freely? This is the problem of free will and determinism, and it's been debated for millennia. But the block universe gives it a new twist. It's not that the laws of physics determine the future by evolving the present forward in time. It's that all moments of time exist simultaneously, and the relationships between them are what they are. Some philosophers argue that free will is compatible with the block universe. Even if your future choices exist timelessly, they're still your choices. You're still the cause of your actions. The fact that they exist in the future doesn't mean you didn't freely choose them when you get to that point in your time-like world line. Others argue that the block universe eliminates real choice. If the future is as fixed and definite as the past, then your feeling of choosing is an illusion. You're not creating the future. You're discovering what was always going to happen. Physicist Sean Carroll at Caltech argues for a middle position. He says that free will is a useful concept at the level of human psychology and decision-making, even if at the fundamental level of physics, all of time exists in a block. Different levels of description can both be true. Now, here's another mind-bending aspect. If the block universe is real, and if time is just another dimension, then the universe doesn't exist in time. It exists as time. The entire timeline is the universe. There's no beyond time, because time is part of what the universe is. This connects to what we discussed about the Big Bang. People often ask, what happened before the Big Bang? But if time itself began at the Big Bang, the question doesn't make sense. Before is a temporal concept, and there was no time before time began. Similarly, people ask, what will happen after the universe ends? If the universe has a final moment in time, there's no after, because after is a temporal concept. The block universe suggests that the universe simply is a four-dimensional object extending through time, with a beginning and possibly an end, but existing as a complete structure. What's beyond the universe temporally might simply be nothing, because beyond implies more time, and there isn't any. But wait. Some cosmological models suggest time might be cyclic. The universe could undergo cycles of expansion and contraction, big bangs followed by big crunches, repeating eternally. Physicist Roger Penrose has proposed a model called conformal cyclic cosmology, where each cycle of the universe becomes the big bang of the next cycle. If time is cyclic, then the beyond of our current cosmic cycle is the previous cycle and the next cycle, extending infinitely in both temporal directions. Or time might be infinite in the future, but finite in the past, as most current cosmological models suggest. The universe began 13.8 billion years ago, but will continue expanding forever. In this case, the temporal beyond is an infinite future, containing everything that will ever happen, all of which exists in the block universe structure. What exists beyond the universe temporally? It might be nothing, or it might be infinite time in one or both directions. or it might be cyclic time repeating forever. But in the block universe view, all of it exists eternally, timelessly, as a single four-dimensional structure. And you are part of that structure, your entire life from beginning to end, inscribed into the fabric of space-time itself. We're 2 hours in, and I hope your conception of reality has been thoroughly scrambled and reassembled. We've explored infinite spaces, multiple universes, holographic projections, quantum foam, mathematical realms, simulated realities, and eternal time. But we're not done. Coming up, we're going to get even more personal. We're going to talk about meaning and purpose in a potentially infinite multiverse. We're going to confront the question of whether your life matters if there are infinite copies of you. We're going to explore what modern cosmology tells us about death, identity, and the nature of self. And we're going to end with a perspective on your place in the cosmos that I think you'll find both humbling and empowering. If this video has expanded your mind, hit that like button. If you want more content that pushes the boundaries of what we think we know, subscribe and ring that bell. And drop a comment telling me your biggest takeaway so far. I read every single comment. Let's continue this journey. Here's the question that probably been nagging at you. If there are infinite copies of you living infinite variations of your life across the multiverse, does anything you do matter? If every choice you make, someone else is making the opposite choice. If every triumph and every failure is happening to some version of you somewhere, what's the point? How can your individual life have meaning in the face of infinity? This is the problem of cosmic significance, and it's worth taking seriously. Let me start with what might seem like bad news. From the perspective of the entire multiverse, your individual life is indeed infinitesimal. If there are infinite universes, your universe is one among infinitely many. If there are infinite copies of you, you're one among infinitely many. Mathematically, 1 divided by infinity is 0. But here's what will blow your mind. This conclusion is based on a mistake. It assumes that meaning and significance come from being unique, from being a large proportion of something. But that's not where meaning comes from. Think about it this way. Suppose I told you that Earth is one planet among trillions in our galaxy, and our galaxy is one among trillions in the observable universe. Does that make your life meaningless? Most people would say no. The fact that Earth is cosmically insignificant doesn't make human experiences meaningless. Or suppose I told you that you're one person among 8 billion on Earth. Does that make your relationships meaningless? Does it make your love for your family or your passion for your work any less real? Of course not. Meaning isn't about being a large proportion of the total. It's about the quality of experience, the depth of connection, the authenticity of engagement with life. Philosopher Thomas Nagel wrote about this in his essay, The Absurd. He points out that looking at human life from a cosmic perspective can make it seem meaningless. But this perspective is itself questionable. Why should the cosmic view be more valid than the human view? Your life is lived from the inside, and from that perspective, it's full of meaning. If there are infinite copies of you, that doesn't diminish the realness of your experience. You are having this experience right now. This is your life, your consciousness, your moment. The fact that other versions of you exist elsewhere doesn't make your joys less joyful or your sorrows less sorrowful. In fact, there's an argument that the multiverse makes your choices more meaningful, not less. In a single universe with deterministic laws, you might worry that your choices are predetermined, that you're just following a script written by the initial conditions of the Big Bang. But in a quantum multiverse with branching timelines, your choices create new branches. Every decision you make brings new universes into existence. You are literally creating worlds with your choices. That's not meaninglessness. That's cosmic creativity. Moreover, the multiverse doesn't eliminate uniqueness. Even if there are infinite copies of you, this particular copy, having this particular experience, in this particular universe, exists only once. Your exact conscious experience in this moment is unique. It's never happened before in this universe, and it will never happen again. Philosopher Derek Parfit explored questions of identity and significance in his book, Reasons and Persons. He argued that what matters isn't whether you're unique, but whether you're connected to what you care about. Your relationships, your projects, your values, these create meaning regardless of how many copies of you exist. But let's go deeper. Maybe the question of meaning in the multiverse is pointing us toward a different way of thinking about significance altogether. In Buddhism and other Eastern philosophies, there's a concept called dependent origination, the idea that everything is interconnected, that nothing exists in isolation. You are part of a web of relationships, causes, and effects that extends throughout the universe. The multiverse takes this to the ultimate extreme. You're not just connected to things in your universe. You're connected to all your alternate selves across the multiverse. You're part of a larger structure of possibility and actuality that encompasses all of existence. In this view, meaning doesn't come from being separate and unique. It comes from being part of the whole. Your consciousness is the universe becoming aware of itself. Your choices are the multiverse exploring its possibilities. Physicist Carl Sagan famously said, "We are a way for the cosmos to know itself." In the multiverse, this is even more profound. You are one of infinitely many ways the cosmos is experiencing itself, and each way is valuable precisely because of its unique perspective. Here's what I want you to take away. The multiverse doesn't diminish your significance. It reframes it. You're not significant because you're the only one. You're significant because you are. Your experience is real. Your consciousness matters. Your choices create consequences in your timeline, in your universe, for the people you interact with. The fact that reality is vaster than you imagine doesn't make you smaller. It makes reality bigger. And you're part of that vastness. Let's talk about something everyone thinks about, but rarely discusses in the context of cosmology. Your death. What happens to your consciousness when you die? And does the multiverse change the answer? There's a controversial idea in quantum mechanics called quantum immortality, and it's going to mess with your head. Remember the many worlds interpretation? Every quantum event causes the universe to branch into multiple versions, each representing a different outcome. This includes events that could kill you. Here's the idea. Suppose you're in a life-threatening situation. A quantum event determines whether you survive or die. In the many worlds interpretation, the universe branches. In one branch, you die. In another branch, you survive. But here's the twist. You can only experience the branches where you survive. In the branch where you die, there's no more you to experience anything. From your subjective perspective, you always find yourself in the branch where you survived. Now extend this to all life-threatening situations throughout your entire life. No matter how unlikely, there's always some branch of the quantum multiverse where you survive. From your subjective perspective, you keep finding yourself alive no matter what. This is quantum immortality. It doesn't mean you're immortal in any objective sense. It means that from your subjective perspective, you can never experience your own death. You always find yourself in the branch where you survived. Physicist Max Tegmark has discussed this idea, though he's skeptical about its implications. The problem is that while you can't experience your own death, you'll still age. You'll still experience suffering, disease, and the gradual breakdown of your body. Quantum immortality doesn't make you ageless. It just means you subjectively experience increasingly unlikely survival scenarios. Eventually, you might find yourself in extremely improbable situations, kept alive by increasingly unlikely quantum fluctuations. This could be a nightmare scenario rather than a comforting one. But let's think about this differently. What is death, really? Is it the cessation of your body's biological functions? Or is it the end of your consciousness? These might not be the same thing. Your body is made of atoms. Those atoms existed before you were born, and they'll exist after you die. They'll be recycled into other things, plants, animals, the ocean, the atmosphere. In a sense, the matter that makes you up is immortal. It's just constantly changing form. Your consciousness, though, seems to depend on a particular pattern of organization in your brain. When that pattern is disrupted by death, your consciousness ends. Or does it? Some interpretations of quantum mechanics and consciousness suggest otherwise. If consciousness is fundamental, as some theories propose, then it might not end when your brain stops functioning. It might transform, change form, or continue in some way we don't understand. Physicist Roger Penrose and anesthesiologist Stuart Hameroff have proposed a controversial theory called orchestrated objective reduction, which suggests that consciousness arises from quantum processes in structures called microtubules inside neurons. If this is true, then consciousness is fundamentally quantum mechanical. In quantum mechanics, information is never truly lost. It can become scrambled or inaccessible, but it's always conserved in some form. If consciousness is quantum information, then maybe it's not destroyed at death, but transformed into a different form. I'm not saying we have evidence for life after death. We don't. But the intersection of quantum mechanics, consciousness studies, and cosmology opens up possibilities that are at least worth thinking about. Here's another angle. If the universe is a mathematical structure, and if all mathematical structures exist, then every possible configuration of consciousness exists as a mathematical reality. That includes not just you now, but every possible past and future state of your consciousness. In this view, your consciousness doesn't really end at death. It exists eternally as a mathematical structure, a pattern of information. Death is just the end of one temporal slice of that pattern. Or consider the block universe. If all of time exists eternally, then every moment of your conscious experience exists forever. The you experiencing this moment is eternal in the four-dimensional structure of spacetime. Death is just the boundary of your time-like world line, but the experiences you've had are permanently inscribed in the fabric of reality. These ideas don't constitute proof of immortality, but they do suggest that the relationship between consciousness and physical existence is more subtle than simple materialism would suggest. Here's what I think is important. Regardless of what happens after death, the consciousness you're experiencing now is precious and finite. Even if there are infinite copies of you, even if your consciousness somehow persists in some form, this particular experience, this particular moment, is unique and irreplaceable. That makes it meaningful. That makes it worth cherishing. Death doesn't diminish meaning. If anything, the finitude of individual experiences is what gives them poignancy and value. The fact that this moment will pass is what makes it important to be fully present for it. Why does the universe seem perfectly calibrated for life to exist? The fundamental constants of nature, the strength of gravity, the mass of electrons, the speed of light, all have values that seem incredibly fine-tuned. Change any of them by even a tiny amount, and life as we know it couldn't exist. This is the fine-tuning problem, and the multiverse might provide an answer. But it's an answer that reveals something profound about your existence. Let me give you some examples of fine-tuning. The cosmological constant, which governs the expansion rate of the universe, has a value of approximately 10 to 122 in Planck units. If it were larger by even a factor of 2, the universe would have expanded too quickly for galaxies to form. If it were smaller or negative, the universe would have collapsed before stars could form. The ratio of the strong nuclear force to the electromagnetic force is about 100 to 1. If this ratio were slightly different, atomic nuclei wouldn't be stable. Chemistry as we know, it couldn't exist. The mass difference between neutrons and protons is tiny but crucial. If neutrons were slightly lighter or protons slightly heavier, hydrogen atoms would decay, and there would be no water, no organic chemistry, no life. These are just a few examples. Physicist Martin Rees identified 6 fundamental numbers that seem fine-tuned for life in his book. Just 6 numbers. Change any of them, and the universe would be radically different and almost certainly lifeless. So why do these constants have the values they do? There are three main types of answers. First, pure chance. Maybe there's no explanation. The constants are what they are, and we're lucky they allow for life. This seems unsatisfying because the degree of fine-tuning is so extreme, but it's logically possible. Second, design. Maybe the universe was deliberately set up with these constants to allow for life. This is the intelligent design argument. It's philosophically coherent, but doesn't explain who or what did the designing, or why. Third, the anthropic principle and the multiverse. If there are many universes with different constants, we necessarily find ourselves in one of the rare universes where life is possible. This isn't luck, it's selection effect. The anthropic principle was named by physicist Brandon Carter in 1973, though the idea is older. It comes in two versions, weak and strong. The weak anthropic principle says, we observe the universe to have properties compatible with life, because if it didn't have those properties, we wouldn't be here to observe it. This is trivially true, but explains the fine-tuning. We're sampling from the subset of possible universes that allow for observers. The strong anthropic principle says, the universe must have properties that allow life to develop at some point. This is more controversial because it seems to give observers a privileged role in determining cosmic properties. If the multiverse exists, the weak anthropic principle provides a natural explanation for fine-tuning. Among the vast ensemble of universes with different constants, most are lifeless. But we can only find ourselves in one of the rare universes where the constants allow for complexity, chemistry, and life. This isn't just speculation. String theory, one of our best candidates for a theory of quantum gravity, predicts a vast landscape of possible universes with different properties. Physicist Leonard Susskind has estimated there might be 10,500 different possible universes in the string landscape, each with different constants and laws. If eternal inflation is correct, all of these possibilities are realized somewhere in the multiverse. Our universe, with its life-friendly constants, is just one island in an infinite ocean of universes. But here's what will blow your mind. The anthropic principle suggests that your existence is evidence for the multiverse. The very fact that you exist, that you're able to ask why the universe is fine-tuned, is evidence that there are many universes, and you're necessarily in one of the rare ones that allows for life. Your existence is not miraculous in the sense of violating probability. It's necessary given the structure of the multiverse. Somewhere in the vast ensemble of universes, observers like you must exist, and you can only ever find yourself where observers can exist. This is a radical shift in perspective. Instead of seeing yourself as an unlikely accident in a single universe, you see yourself as an inevitable consequence of a multiverse exploring all possibilities. Some physicists dislike the anthropic principle because it seems to give up on finding deeper explanations. Why should we settle for, we observe these constants because we couldn't exist with different constants, when we might be able to discover a deeper theory that predicts the constants? Others embrace it as a legitimate explanatory principle. If the multiverse exists and explores all possibilities, anthropic reasoning is the correct way to explain certain observations. But here's the deeper philosophical point. The anthropic principle connects you to the structure of the cosmos in an intimate way. The universe isn't just the stage on which your life plays out. Your ability to observe the universe is part of the explanation for why the universe has the properties it does. You are not separate from the cosmos. You are the means by which the cosmos understands itself. The fine-tuning that allows for your existence is not a cosmic coincidence. It's a necessary feature of any universe that contains observers asking these questions. In a sense, your consciousness completes the universe. Without observers, the cosmos would be a meaningless collection of particles and fields. With observers, it becomes something that knows itself, understands itself, questions itself. You are not an insignificant speck in an indifferent universe. You are the universe's way of being significant? We've explored multiple types of beyond, spatial infinities, bubble universes, quantum many-worlds, holographic boundaries, Planck-scale quantum foam, mathematical platonic realms, simulated realities, eternal time, and the anthropic multiverse. But there's one more beyond we need to confront: the limits of what we can possibly know. What if there are fundamental limits to knowledge? What if some truths about reality are forever beyond our capacity to discover? This isn't pessimism. It's a recognition of deep facts about the nature of knowledge itself. Start with mathematics. In 1931, logician Kurt Gödel proved his incompleteness theorems. He showed that in any consistent formal system powerful enough to describe basic arithmetic, there are true statements that cannot be proven within that system. No matter how many axioms you add, there will always be truths you can't reach. This is a fundamental limit on mathematical knowledge. It's not about human limitations or lack of cleverness. It's built into the structure of logic itself. Does something similar apply to physics? Are there truths about the physical universe that we can never know, not because of practical limitations, but because of fundamental limits on what knowledge is possible? Physicist Stephen Hawking wrestled with this question throughout his career. He initially believed we might find a theory of everything that would explain all physical phenomena. But later in his life, he became more skeptical, suggesting that Gödel's incompleteness might apply to physics as well. The holographic principle suggests that there might be a fundamental limit to how much information can be contained in any region of space. This puts a bound on how much we can possibly know about that region. The cosmic horizon puts a limit on what regions of the universe we can observe. Events beyond our horizon are fundamentally inaccessible to us, not just practically, but in principle. And if we're in a simulation, the programmers could hide aspects of the underlying reality from us, making some truths permanently unknowable. But here's the most profound limit. Consciousness itself might be fundamentally mysterious. The hard problem of consciousness, why there's something it feels like to be you, might not have a solution in terms of physical processes. Consciousness might be one of those aspects of reality that can't be fully explained by anything more fundamental. Philosopher Colin McGinn has argued for what he calls Mysterianism, the position that human cognitive architecture might not be capable of understanding consciousness. Just as a dog can't understand quantum mechanics, humans might be constitutionally incapable of understanding certain aspects of reality. This doesn't mean we should stop trying to understand. It means we should be humble about the limits of our understanding. Here's what will blow your mind. The existence of fundamental limits on knowledge might itself be a clue to the nature of reality. If there are truths we can never know, that suggests that reality is richer than any description of it can capture. Reality transcends our concepts, our theories, our explanations. This is sometimes called the apophatic approach to understanding, through acknowledging what we cannot understand. It's common in mystical traditions, but it has a place in science as well. Physicist Werner Heisenberg, one of the founders of quantum mechanics, said, "What we observe is not nature itself, but nature exposed to our method of questioning. Our knowledge is always partial, always filtered through our methods and our concepts. The universe doesn't owe us comprehensibility. The fact that we've understood as much as we have is remarkable, perhaps even miraculous. But there may be aspects of reality that will forever remain beyond our grasp." And yet, here's the paradox. Even acknowledging limits to knowledge is a form of knowledge. Knowing what we can't know is itself a kind of understanding. Maybe the ultimate beyond of the universe is this: reality is always richer, deeper, more complex than any finite mind can fully comprehend. There's always more to discover, more to question, more to wonder about. This isn't a bug, it's a feature. It means the universe can never become boring, never become fully mapped, never become exhausted of mystery. What exists beyond the universe? Perhaps the most honest answer is more than we can imagine, more than we can discover, more than we can know. And that's beautiful. Let's bring this all together and make it personal one more time. After everything we've discussed, infinite universes, quantum foam, holographic projections, mathematical reality, consciousness, death, fine-tuning, and the limits of knowledge, what does it all mean for you? Here's what I want you to understand. You are a miraculous intersection of multiple levels of reality. Physically, you're made of atoms forged in the cores of stars billions of years ago. The iron in your blood, the calcium in your bones, the oxygen you breathe, all of it was created in stellar furnaces and scattered across the cosmos when those stars died. You are literally made of stardust. This isn't poetry. It's astrophysics. Biologically, you're the product of 3.8 billion years of evolution, an unbroken chain of survival and reproduction stretching back to the first self-replicating molecules. Every one of your ancestors successfully survived long enough to reproduce. You carry that legacy in your DNA. Cosmically, you exist in a universe fine-tuned for complexity. Had the constants of nature been slightly different, you couldn't exist. The universe had to be precisely calibrated for stars to form, for planets to coalesce, for chemistry to become rich enough for life. Consciously, you're a subject of experience. You're not just a collection of particles following physical laws. You're a being for whom there's something it's like to exist. You have inner experiences, subjective feelings, the mysterious phenomenon of consciousness. Mathematically, you're a pattern of information, a structure in the vast landscape of mathematical possibilities. If mathematical structures are real, then you exist not just as matter, but as a mathematical object, eternal and unchanging in the space of abstract forms. Quantum mechanically, you're constantly branching into multiple versions across parallel timelines. Every quantum measurement creates new versions of you, exploring different possibilities. Temporally, if the block universe is real, your entire life exists as a four-dimensional object in space-time, eternal and complete. You are all of these things simultaneously. Your matter, energy, information, consciousness, mathematical structure, quantum superposition, temporal extension. You're a meeting point of multiple levels of reality. And here's what's crucial. None of these perspectives negates the others. You don't have to choose between being stardust and being conscious, between being a physical body and being a mathematical pattern. You're all of it at once. This is what philosopher Daniel Dennett calls the manifest image versus the scientific image. The manifest image is how you experience yourself, as a unified agent, making choices, having experiences, living a life. The scientific image is how physics describes you, as particles, fields, quantum states, information. Both images are true. They're just different levels of description. The scientific image doesn't replace the manifest image. It complements it. So what should you do with this knowledge? How should you live in light of everything we've discussed? First, cultivate wonder. The universe is far stranger and more beautiful than everyday experience suggests. You live in a cosmos of infinite depth, infinite possibility, infinite mystery. Let yourself be amazed by that. Second, embrace your significance. Yes, you're physically small. Yes, there might be infinite copies of you elsewhere. But you are the universe becoming conscious of itself. That's not small. That's profound. Third, take responsibility for your choices. Whether or not you have free will in some ultimate metaphysical sense, you experience making choices, and those choices have consequences for you and the people around you. Live deliberately. Fourth, connect to something larger. You're not separate from the cosmos. You're part of it. Your consciousness is connected to the fundamental fabric of reality. Find ways to feel that connection. Fifth, Pursue knowledge, but hold it humbly. We've learned an enormous amount about the universe, but we've barely scratched the surface. There's always more to discover. Be intellectually curious, but don't pretend to certainty where uncertainty exists. Sixth, find meaning in your direct experience. The multiverse doesn't diminish your relationships, your passions, your joys, your sorrows. Those things are real and meaningful, regardless of what exists beyond the universe. Seventh, remember that you're temporary, but your impact isn't. The connections you make, the ideas you share, the kindness you show, these ripple outward through space and time. In the block universe, they're eternal. You are a conscious being, made of star stuff, existing at a specific point in space-time, experiencing one timeline among many possibilities, connected to mathematical and quantum realms beyond ordinary perception, asking questions about the ultimate nature of reality. That's not small. That's not insignificant. That's miraculous. We've reached the final section, and I want to leave you with a perspective that synthesizes everything we've discussed. What exists beyond the universe? After exploring spatial infinities, temporal eternities, quantum multiverses, holographic boundaries, mathematical realms, and conscious experience, I think the deepest answer is this: you do. Not just physically, but ontologically. You're not contained by the universe. You're part of what the universe is, what it's becoming, what it's discovering about itself. The boundary between you and the cosmos is permeable, maybe even illusory. Your atoms came from stars. Your consciousness might be a fundamental feature of reality. Your observations affect quantum states. Your existence requires the entire universe to have specific properties. You're not a separate thing inside a container called the universe. You're a process through which the universe understands itself. Philosopher Alan Watts expressed this beautifully. You are an aperture through which the universe is looking at and exploring itself. Every time you observe the stars, the universe is looking at itself. Every time you wonder about the nature of reality, the universe is questioning itself. This isn't mystical nonsense. It's a straightforward consequence of the fact that you're made of the same stuff as everything else, following the same laws, participating in the same cosmic story. But there's something even deeper. The question, what exists beyond the universe, might be pointing to a fundamental truth about existence itself. Existence is irreducibly mysterious. We can discover laws, make predictions, build models, explore territories of knowledge. But at the foundation of it all is the sheer mystery that anything exists at all. Why is there something rather than nothing? This might be the ultimate unanswerable question. Philosopher Martin Heidegger called this the fundamental question of metaphysics. He argued that we've become so accustomed to the existence of things that we forget to be amazed by existence itself. Things exist. That's weird. That's wondrous. What exists beyond the universe? Existence itself. Being. The fact that there is something rather than nothing. This is the ultimate beyond, because it's what makes all other beyonds possible. And you participate in that mystery. You are existence becoming aware of itself, being asking what it means to be. Now, let me address something directly. Some of you might be feeling overwhelmed or even anxious about what we've discussed. The infinity of the multiverse, the possibility that we're in a simulation, the limits of knowledge, the strangeness of consciousness, these ideas can be unsettling. That's okay. It's normal to feel disoriented when your conception of reality is challenged. But I want you to know that this disorientation can be productive. It can open you to new ways of thinking, new possibilities, new appreciation for the mystery of existence. You don't have to believe everything we've discussed. These are theories, models, frameworks for thinking about reality. Some will turn out to be true, some false. Some will be refined and modified as we learn more. What matters is that you've expanded your sense of what's possible. You've seen that reality might be far stranger and more wonderful than everyday experience suggests. You've confronted the biggest questions humans can ask. And you've discovered that these questions aren't abstract philosophical puzzles. They're intimately connected to who you are, how you exist, what your consciousness is, and what your place in the cosmos might be. Here's my final challenge to you. Don't let this knowledge remain merely intellectual. Let it change how you engage with life. Look up at the stars and remember you're seeing light that traveled for years or centuries or millennia to reach your eyes. That light is a message from the past, from other parts of the cosmos. Look at your own hands and remember they're made of atoms forged in stars. You're literally touching stardust. Make a choice and remember, you might be creating a new branch in the quantum multiverse. Your choices might have cosmic significance. Experience consciousness and remember it's the most mysterious phenomenon in all of reality. Nobody fully understands why there's something it's like to be you. Feel time passing and remember you're moving along your world line through the four-dimensional block of space-time. Connect with other people and remember there are other centers of consciousness, other apertures through which the universe sees itself. The universe isn't something separate from you that you're studying from the outside. You're part of it. You're how it experiences itself, understands itself, questions itself. What exists beyond the universe? In one sense, infinite space, other universes, quantum possibilities, mathematical forms, holographic boundaries, simulation substrates, temporal eternities, and mysteries we haven't even imagined. In another sense, nothing, because the universe is all of space, time, matter, and energy. In the deepest sense, you, your consciousness, your experience, your participation in the mystery of existence. You are not separate from what exists beyond the universe. You are part of what the universe is and what it's becoming. We've been on a 3.5-hour journey through the deepest mysteries of existence. We started with a simple question: what exists beyond the universe? And discovered that the answer involves infinite space, multiple universes, quantum branching, holographic projections, mathematical realms, simulated realities, eternal time, consciousness, fine-tuning, and the limits of knowledge. But more importantly, we've discovered that this isn't just an abstract question. It's a question about you, your place in reality, the meaning of your existence. You are a conscious being in a possibly infinite multiverse, made of atoms forged in stars, following quantum laws, experiencing time as a flow through the block universe, existing as both matter and information and mathematical structure and conscious experience. You are miraculous, not because you're separate from the natural world, but because you're a manifestation of what the natural world can do when it organizes itself into patterns of sufficient complexity. The universe is not a dead, mechanical thing. Through you and other conscious beings, it's alive, aware, questioning, wondering. What exists beyond the universe? Mystery, wonder, possibility, and you experiencing it all. I want to thank you for taking this journey with me. If you've made it this far, you've engaged with some of the deepest questions humans can ask. You've expanded your mind, challenged your assumptions, and confronted the profound strangeness of existence. If this video has changed how you see reality, hit that like button. If you want more content exploring the biggest questions in science and philosophy, subscribe and turn on notifications. I have so much more to share with you. Drop a comment telling me your biggest takeaway from this video. What concept challenged you the most? What idea are you still wrestling with? What questions do you still have? I read every comment, and your thoughts help me create better content. Share this video with someone who loves deep questions. This kind of content doesn't get promoted by algorithms unless viewers like you share it. Help me spread wonder and intellectual curiosity. And remember, the universe is stranger than you imagined. Reality is deeper than it appears. And you are part of the cosmic story, not separate from it. Keep questioning. Keep wondering. Keep expanding your sense of what's possible. The cosmos is vast, but you are not insignificant. You are how the cosmos knows itself. Thank you for watching. Until next time, keep looking up, keep asking questions, and keep marveling at the mystery of existence.